today we're starting a new unit, and we're starting with a really basic piece of factoring. But before we even get into what factoring is or where we're moving towards, I want you to go ahead and do this warm-up where it really goes back a couple units ago to our polynomials unit, and it's asking us to distribute or really just multiply these terms through. So first go ahead and do that, and then pause the video and then restart the video and see how you do. Okay, so you can see I distributed 4 here, giving me 4x plus 28, multiplying each term by 4, multiplying each term by 5x, and then last distributing this 3x through. Okay, that's where we've been in unit 5. That's what we've done before. What we're going to look at now is really the opposite of this, where we want to factor apart a polynomial, which means we want to break it down into its factors. And so before we get started, let's talk about what a factor is. So a factor is a number or term that divides evenly into another term. So for example, I just look at a random number, so 24. Factors of 24. So one possible factor of 24 would be 2, right? 2 is a number that divides in evenly to 24. 2 times 12 is 24. So both 2 and 12 are factors of 24. They both divide in evenly. 1 times 24, 4 times 6, 3 times 8. These are all factors of 24. They're all numbers that divide evenly into our original number 24, okay? Now, when we start adding variables and exponents, things get a little more involved. So then it asks, well then, okay, what would be the factors of 30x squared? So now, maybe I have 3x times 10x, right? 3x divides in evenly, 10x divides in evenly. If I multiply them together, it would give me 30x squared. So I've taken 30x squared, I've broken it apart into 2 of its factors. Maybe we have 5x and 6x, or x times 30x. Maybe we have 2x times 15x. You can kind of get this picture of there's all sorts of factors that would work for 30x squared. And it goes beyond this, because -3 times -10, and negative times a negative is also going to give me a positive 30x if I were to multiply them back together. Okay, they also divide in evenly. Or -5x times -6x, and so on. Or I could have had just the x squared term on one of my factors. So for example, 3x squared times 10. That's another set of factors for 30x squared. Or 10x squared times 3. Then I can flip it around, which one has the x squared and which one doesn't. Okay, and so on. And there'd be a whole bunch of other factors we could create kind of in this likeness. Okay, so once we get into a variable, it really expands all the possibilities that we could be looking at for our factors, okay? Now, we're starting factoring. Our entire unit is on factoring polynomials, and we're starting by looking at just factoring out a GCF, okay? So it says factor, that should probably say the polynomials. And really, we're gonna look to factor out the GCF. GCF meaning the greatest common factor. So what's the largest number that divides in evenly to all terms? Okay, that's an important piece. We're not just looking at the first term and what are the factors of the first term, but when we have a polynomial, we're looking at all of our terms and deciding what can we factor out of all of the terms there. In this case, these 2 terms. So looking at 4x and 28, for example, just to talk about GCF, I could divide them both by 2 evenly, but that's not the greatest number that I could divide them by. I can also divide both 4x and 28 by 4. So the greatest common factor would be to divide a 4 out of each of those terms. Now that 4 is not going to go away. I'll say that this polynomial is 4 times, and then what does that leave me with? If I take 4x and divide by 4, I'm left with x. 28 and divide it by 4, I'm left with 7. And here are factors of that original polynomial, just like these were factors up above. Okay, it doesn't disappear taking out that factor of 4, it's just going to go out front, and then I'll be left behind with what that result of dividing by 4 would be. So let's look at our next one. So now just looking at the integers 10 and 15, so I can divide both of those terms by 5. And then I have x squared and x. And if I want to be able to divide all of my terms evenly by this GCF, I have to go to x to the first, my least variable there. So this 5x, again, not disappearing, it's a factor out front, times what would be left here. So 10 divided by 5 giving me 2. X squared divided by x giving me x to the first. Plus 15 divided by 5 giving me 3, and x divided by x would cancel out. Now our last example is a trinomial. So now I have to look at all 3 terms and decide what's the greatest that divides in evenly to all 3 of these terms. Now all 3, 12, 6, and 15 can be divided by 3. And then for my variable part, again, I have to go with the smallest variable amount because I need to be able to divide out of this term as well. So I'm going to divide out 3x. And each term individually, I'll divide by 3x. So 12 divided by 3 is 4. X cubed divided by x is x squared. 6 divided by 3 is 2. X squared divided by x is x. 15 divided by 3 is 5. And these x's cancel. Okay, so there's our beginning of how we're going to start factoring. It's just taking out what are the common factors between all of the terms. Now, let me zoom out a little bit. Let's look at this warm up again. Look at that. Okay, see the problems we started with? Those are the factors we just created down here. So what we had been doing in unit 5 is going from here and multiplying it out and getting a polynomial. Now we're starting with that polynomial and we're pulling it apart into two factors. Okay, they're backwards from each other, that warm up in the problems we just did. So we use the distributive property to multiply polynomials, and we use factoring to reverse the process, expressing the polynomial as a product. So a few more examples here of that kind of opposite thing happening. In our polynomials unit, if we had seen this, we would have distributed a through and we would have had ab plus ac. Now we're going to start with something like ab plus ac and say, well, they share a common factor of a, so I'll divide that out, leaving me with b plus c. Okay, opposites here, what we're doing. In our unit 5, we would have distributed 4x through, giving me 12x squared minus 20x. In this unit, we're going to start with the polynomial, decide what we can divide out of both of them, being 4x here, dividing that out, giving me 3x minus 5, okay? Reversing our multiplication process, factoring it, pulling that polynomial apart into a product of 2 terms. Okay, so flip this page over. Now this is an important piece, and the reason we start with factoring out a GCF is it's not always possible. There's not always a common factor between your terms. But for any factoring problem, so even when we get way more involved into factoring later in this unit, the very first step we should take is to look for the GCF. Okay, we always need to take a moment and see, is there a GCF that is contained in all of my terms? And if so, then I need to factor that out first. Now, the variable part of the GCF will always contain the least exponent, meaning if there's a term with no exponent or no variable at all, then I'm not going to be taking out a variable term. If I have an x cubed, for example, or y cubed in a y, then I can only take a y out of all of my terms because it has to be divisible by this term here with the smallest exponent value. Okay, So let me do a few of these with you and then I'll let you try a few on your own. So we were talking about this one. For my variables, I can only take out a y. 24 and 32, they share a lot of factors, but I want to take out the greatest common factor. So I want to take out 8 from both of those terms. And that would leave me with 3y squared. So I'm just dividing 24y cubed by 8y. And then I'll divide 32y by 8y, giving me 4. And the way that I know that I've taken out the greatest GCF is that what's left behind shouldn't share any common factors, what's left in my parentheses. Let's continue to go down this column. So here, I can divide both of those integers by 18, and then I have n cubed and n to the 7th, so I can take n cubed out of both terms. Now, when I divide 18n cubed by 18n cubed, it doesn't disappear. A number divided by itself is 1. Plus 18 divided by 18 is 1, n to the 7th over n cubed, giving me n to the 4th. Okay, and we have to remember that it's the opposite of multiplication. So if I were to multiply that back through, that 1 is going to give me this first term that's here. Okay, so that's another way to think about what happens when you're dividing a term actually by itself. Next one, so 15, 12, and 27. The greatest common factor between those integers would be 3. And looking at my variable term, the most I can take out is m to the 1st. So again, that doesn't disappear. I have 3m. And then 15 divided by 3 giving me 5. M to the 4th divided by m, just subtracting exponents here, m cubed. 12 divided by 3, 4. 2 take away 1 leaves me with 1m. Negative 27 divided by 3 is negative 9, and these m's would cancel. Again, I can check, these don't share any common factors, 5, 4, and 9, so I know I took out the greatest common factor. Now let's look at the one in the bottom of this row. This is tricky. So what you may notice is that they have a comment that the parenthesis repeats itself. So this is the common factor, that I have a squared times this and I have 5 times this same parenthesis. And so I can divide out a plus 3 here and I can divide out the a plus 3 here. Or really I can take that entire polynomial and just take a plus 3 out front. And when I divide out a plus 3, it leaves me with a squared plus 5. So instead of taking out a common single term, I'm taking out a common binomial or a common parenthesis. There's one more I want to look at with you, and then I'll let you try a few on your own, and that's just with more than one variable. So let's look at this xy problem here. So I don't have any integers to worry about. For my x's, again, I have to go to the smallest amount. That's the most I can take out. So I have x cubed, and then y cubed is the smallest I can take out for my y. So I have x cubed, y cubed that I can factor out. And then for each one, it's little properties of exponents. So I have 5 take away 3 x's, leaving me with 2 x's. And 3 take away 3 is going to leave me with no y's for that first term. For my second term, I have 4 take away 3, so 1x. 4 take away 3, 1y. And for my last term, 3 take away 3, so all my x's will cancel. Oh no, did I take out the wrong amount? I did. This is y squared, so I can only take out y squared. I'll go back to my other two terms in a minute. X cubed, y squared, those would all cancel out or leave me with 1 here. So I messed up on my y, so that's okay. I don't have to redo the whole problem. I was only supposed to take 2 out. So that means on my first one, 3 take away 2 is going to leave me with 1 y. 4 take away 2 is going to leave me with 2y there. Okay, I just had to go back and edit my first two terms because it would change when I'm dividing out. Okay, so now I want you to go through the remaining problems and decide what is the GCF, divide it out, and write it as a product of two factors instead of just a polynomial written together. So pause your video and then restart when you're ready to check your work. Okay, so let's go through these problems that we hadn't discussed yet. So first couple are pretty straightforward, what you're taking out for a GCF, and then just kind of check with what you have left behind. The second one, all you can divide out is a 3 from both terms. In the second row, we again have multiple variables. So at the most I can take out for x is x to the first and y squared. And that's what's left behind in my parenthesis. This trinomial, I can take 4p cubed out, leaving me with this factor of 4p squared minus 3p plus 1. We've done these two. Again, here, all I can take out is an integer because this last term is a constant, so I can't take out a variable from that. And then the last row, it goes back to this type of problem where I'm dividing out a common parenthesis, okay, where they both share a factor of y plus 1. I divide that out, and it leaves me with x minus 2. And here I can divide out the x plus 4, and it leaves me with 3x minus 1. Now this one's a little bit tricky because there was nothing here. So that's like that ninja 1. That's where that minus 1 comes from.